Today we're going to talk about how to simplify radicals. So in our first example here, we have 216. Well, whenever we simplify, we're always looking for perfect squares. And the reason we're looking for perfect squares is because this is a square root. And we know this is a square root because of that invisible 2 there. So that means I want everything on the inside here to have a pair. I want it to be a square. The reason, again, I want it squared is because it's the inverse of this square root here. So the first thing I need to do is break down this 216. And how I do that is I use my perfect squares that I learned and work backwards. So I'm going to have 216 divided by 196. That's not a whole number, so I keep going. 216 divided by 169. It doesn't work. 216 divided by 144. Still doesn't work. And since I know the answer, I'm going to jump down a little bit to get closer. 49 doesn't work, but 36 does. So 36 is a perfect square in 216. So I'm going to write this as a 36 and a 6. Now 36 is a perfect square of 6 and 6. So there's my pair, and this guy's a square, he's a loser. So now I write my square root out. I have 2 6's, and the 1 6 that's a loser and has to stay home. So I circle my pair, square the losers, so this 6 is going to come outside. Now when it comes outside, it loses this 2, and the reason it loses the 2 is because of this index 2 right here, remember, this invisible 2. So this invisible 2 and this 2 are inverses, so I'm just left with a 6 on the outside with a 6 on the inside. And that's how you simplify. We'll do another one. Let's say we have 75. Well, I need to go back to my perfect squares again. So 75, I'm going to have to start at 64. Doesn't work. Try 36, doesn't work, and I skipped one. 49 also doesn't work. So then the next one is 25, and that one works. So I have 25 and 3. If I break this into 25 and 3, now I know 25 is 5 and 5. So there's the pair that I was looking for, and here's the loser that has to stay home. So now I write my square root. I have 5 squared, there's 2 of them, times the 3. I circle this pair, I square that loser, and now this pair comes outside because it's the inverse, so it undoes that square root. So I'm left with the 5 square root of 3. And that's my answer. Let's make it a little more complicated. Let's say that we have 147 m cubed this time. Again, we still want to make everything a pair. So we know there's 3 of these in here, but we just want pairs, so we want 2 of them. So you need to keep that in mind. Now this 147, I'm going to break that down. So 147 divided by 144 does not work. 121 does not work. 100 does not work. 81 doesn't work. That doesn't work. But that one does work. So 49 and 3 is what I can break 147 into. So I have 49 and 3 here. Now this 49 breaks into 7 and 7. So there's my pair, and here's a loser. Now if it helps, what we can do is we can break this m squared down also. I can break that, or this m cubed, I can break that into an m squared and an m, and there's my pair, and there's my loser. So now I have the square root of 7 squared, 3, an m squared, and an m. Again, the reason that this is an m squared and an m is I'm always trying to get pairs, and since this has an invisible 1 there, 2 plus 1 gives me the 3 that I started with originally. So I just broke it down into a 2 and a 1 so that I can circle these pairs so that they can come out and the 3 and the m have to stay inside. So the 7 comes out and the m comes out, and then that 3 and the other m stays on the inside. And that's your answer. Let's do another one. Let's say we have -4 radical 192 x cubed y to the 8th. Alright, so again, keep in mind you just want to have squares, so I need to break down this 192 into a perfect square. So 192, let's start at, let's see, 144. That doesn't work. 121 doesn't work. 100 doesn't work. No. And 64 works. So 192 can be broken into 64 and 3. So 64 and 3. Now this 64 is a pair of 8 and 8. So there's my pair. Here's my loser. So now when I write this, I have -4 square root 8 and 8, so there's a pair there, times that 3, and now this cube that we had earlier, the x cubed, I'm going to break that down like we did in the previous one. I know I can have 2 because there's a pair, and then that leaves 1 left over. Again, 2 and 1 make 3. Well, 8, I can break that down, so I have a 2 there, that makes 4, that makes 6, and that makes 8. Now I circle all of these pairs, and then square my losers, the 3 and the x. Now you'll notice that we have a number outside of this radical here. Well, whenever these things come out, they always multiply. So I have -4 times the 8 that comes out. The 3 stays on the inside, the x comes out. And then I have these 4 y's that come out. There's 1, 2, 3, 4. Square root, and what's left is the 3 and the x. And now I simplify. -4 times 8 is -32 with an x, and then I have y times y times y times y. Well, if you remember back to your rules of exponents, these all have 1s, and when you multiply, you add the exponents, so 1 plus 1 plus 1 plus 1 is 4y's with a 3x left on the inside. And that is how you simplify radicals.